Hi everyone, and welcome back to Physics 11. So in this video, we're going to be looking at a new unit, electric circuits. So on this first slide, we have two diagrams. We have a pictorial diagram, and on the left, we have a schematic diagram. So the pictorial circuit diagram shows each of the circuit elements as actual pictures or images of each of the elements. In this case, we have a switch, we have a light bulb, and a battery. And on the left side, we have a schematic diagram, which is basically showing the same elements, but represented in much more simpler ways. So for example, if you have a simple circuit, it might be okay to draw something like this. But if you have something with a few more elements, then it becomes quite a lot of work to do, and it's just basically, it's not practical. So we're going to look at how we can represent different elements using schematic diagrams, and as well look at a couple of different ways how we can connect elements in a circuit. Now, before we get to circuits, perhaps you recall from your junior sciences how static electric charges interact with one another. So if you remember, these are fixed electrical charges. They're not the same as the electricity that we use everyday life. So when we talk about static charges, we're talking about charges that are not moving. You can basically create static a charge. For example, if you rub your feet on the carpet and then you touch something metal which is grounded, and you feel like you got zapped. So same thing with lightning. The clouds will discharge static charge that accumulate in the cloud through the shortest distance to the ground. So that would be an example of static electricity. So basically it can accumulate charge, and at some point it might discharge because you grounded it. But when we talk about, again, electricity, we're talking about the flow of electrons. So electricity is normally flow of electrons. You can also have ions, which will create a flow as well. But everyday life, we're definitely talking about flow of electrons. When you take chemistry 12, you will talk more about redox equations and how batteries work and stuff like that. So you'll learn more about this later on. And definitely in physics 12, you would talk more about circuits. So again, when we're talking about everyday electricity, we're talking about current of electrons. But in order to have a current, we have to have two things. We have to have a potential difference, and we have to have a complete circuit. So the complete circuit should be fairly obvious. If you don't have a complete circuit, there's no way for the particles to flow, right? So they'll be just standing in a place, just like a static charge. Now, for the potential difference, also known as the voltage source or the electromotive force, the EMF, we're going to get to that later in the unit. Think of it as the gravitational potential difference, right? So for example, if you're on the ground, you don't have any potential energy. If, let's say, you're 10 meters above the ground, now you have some, I don't know, depending on your mass, you will have a certain amount of potential energy. So same thing applies to voltages. So if the battery is dead, is flat, there is no voltage difference between the positive and the negative terminal. But if you have a brand new battery, let's say you have a AA battery, which looks something like this, right? You have your plus side, and that's your negative side, and the voltage should show as 1.5, right? So 1.5 volts, it's a brand new battery. That means that the difference between the voltage between the positive side and negative is 1.5 volts. Oops, I went backward there. So some examples of voltages are batteries and, of course, electrical outlets. Now, batteries are what's known as DC type of voltage source, and electrical outlets are known as AC electrical sources. So DC means direct current or continuous current, and AC is alternate current. So again, in our case, we're going to be mostly focusing on DC current. I might mention AC current, but again, that's going to be more physics 12 than physics 11. So let's take a look at a simple circuit. So here we have a pictorial circuit diagram. We have a battery, we have two light bulbs. So each light bulb is connected one after another. This is called in series. So the question is, which direction does the current flow? Well, unfortunately, there are two ways you can look at this. When people were first learning about electricity and studying circuitries and how electricity actually works, they thought of it as positive charges moving from positive to negative direction. And then later on, when people discovered electrons, they figured, okay, in reality, it's the other way around. Electrons actually flow from negative to positive side. So again, once they realized that the electrical current was because of an electron flow, then they also discovered that it flows from negative to positive terminal. So there's two ways we can represent electric current. So either using the electron flow from negative to positive, or the conventional current, which flows, which is made of positive charge flow, and it flows from positive to negative terminal. Now, in our case, we're going to be looking at the conventional current flow. So it's always going to be from positive to negative, and we're going to think of it as positive charges rather than negative charges. It's a little confusing, but that's the way, for some reason, people still learn this, and we still use it today. So we're going to learn it the same way, unfortunately. But it's not that hard. I mean, once you understand the difference, it's pretty straightforward. So we need to recall that, again, electric potential is defined in terms of moving a positive charge, not a negative. So, and the direction of the electric field is defined as direction that a positive charge will move in that field. So again, you don't have to worry about the electric field for now. That's, again, something you might learn more about later on in Physics 12. So for us, for now, all we need to remember is that whenever you do circuit analysis, you're always going to think of the conventional current, so from positive to negative, okay? Unless there's something stated in the question, you're always going to treat it as from plus to minus. Like I mentioned, if you take chemistry, you will learn about redox equations, and you learn how batteries work and so on. So you're going to be talking about the same thing. You're going to be talking about electron flow versus the current flow. So here we have some circuit elements, some of the basic circuit elements. So we have a wire, which provides a path for electrons to flow, and the way we represent the wire is just basically a straight line. So you have a straight line like this. Now on the line you might have a node, which shows that you have something connected. So let's say if this is my wire, to show a node, I just need to add a solid dot. So this is called a node. All right. Next, we have cell or a battery. So this provides electric potential difference or the electromotive force. Again, we're going to talk about EMF later on at the end of this unit. And the way to represent the battery is basically this way. So you have one shorter line, vertical line, and then one longer line next to it. So this is going to be a battery. Now you can also show the positive side is on the longer side, so you can add a plus there if you want. So this would be one cell or one battery. Let's say if you want to show a battery that's maybe made up of multiple cells, you can add a couple more, so you can draw it like this. So let's say this may be a battery made up of two cells. For example, a 9-volt battery is made up of a bunch of 1.5 little cells in it. Then we have a light bulb. Now for the light bulb, again, we have a couple of ways we can represent this. The simplest way is just draw a circle and then draw a cross or an X through it, and then you can draw two leads from either side, showing that that's a light bulb. Another way is to kind of draw a squiggly line like so, and then again put it in a circle and add a couple of leads on the sides. So that would be light bulb. And again, a light bulb is just a load or a resistor that, the purpose of light bulb is to produce light, so it's a resistor that emits light. A resistor itself is basically a type of conductor that's less, it reduces the amount of flow compared to the conductor wire. So a resistor is normally represented with this zigzag line, okay? And then we'll have like a label, let's say resistor 1, so we'll say R1. Now another way you might see a resistor represented is going to be, again, a little rectangle with two leads coming out on each side, on the shorter sides of the rectangle. So that'd be another resistor, perhaps shown like that. So usually pick one or the other way. I prefer to use the zigzag line, but you might see in circuits shown like this. And again, the purpose of a resistor is to reduce the electron flow. Now a switch, it basically breaks the circuit apart, so it will disengage and prevent the flow of electrons. So the switch is just basically something like this. So you can have the solid dots there or not. Sometimes it doesn't show, sometimes it's just like this. So this would be the open position, okay? And then when it's closed, of course, it's just gonna be a straight line. So you have to pay attention. Normally on a diagram, you're always gonna show it in an open position to show that there's a breaker somewhere. If you just draw it a straight line, then people won't know that that's a switch there. So whenever you wanna draw and show that there is a switch, you definitely wanna show it in open position, not in closed position. So again, you know you're not going to use the closed position, but that's how it actually works. And then we have a couple of measuring tools. So one of them is a tool that's used to measure the voltage, and this is called the voltmeter. So to represent the voltmeter, you're just going to draw a circle and draw a letter V in it and add a couple of leads on each side. And again, this will measure the electric potential of a cell or a battery. And then we have another tool called the ammeter, which measures the current in the circuit. So the ammeter is very simple as well. It's just a circle with an A and a couple leads on each side. All right, so those are the basic schematics for the basic elements in the circuit. There's lots more, but again, for our purpose, this should be enough for us for now. Now, as I mentioned, we're going to be looking at how we can connect devices or elements to our circuit. And one of the ways is to connect elements in series, which will produce only one path for the current to flow. So in this case, it's asking us to draw a battery of 2 cells connected to 2 resistors in series. So let's say we draw a battery right here. So negative side, negative, positive. So we have 2 cells. And then we have connected to 2 resistors in series. So let me draw one resistor here. So in series means one after another. So this is going to be 1. So this is going to be my R1. Okay. And then I'm going to draw another one down here. So this is going to be my R2. So that means that the current is going to start on the positive side. It's going to go this way. So this is my current. So we use letter I for current. And then this has to go through R1 and then go through R2 and then come back on the other side. So as you can see, there's only one path for the current to go through. There's no alternate way for it to go. So if you have circuits or elements in series, that means that you will create only one path for the current to flow. Now, another way to connect elements in your circuit is by connecting them in parallel, which will produce multiple pathways for the current to flow. So we're going to draw again a battery with 2 cells. So here's my battery. Now in this case, I'm going to draw it like so. I'm going to put my resistor 1. This is going to be my R1. And then I'm going to create a node here where I connected my R1, and I'm going to put on the side another resistor. So this is going to be my R2. So this is in parallel. So the 2 resistors are in parallel. And this means that for the current to flow now, you start from the positive side, right? Your I total goes from here, it goes around, comes to this node right here, and then it has 2 options, either go through R1 or go through R2. And we'll actually split in 2 directions. So you will split your current into 2 parts. You will have your I should say 1, not 2, because this is R1, so this is going to be I1. And here you're going to have your I2 going this way. So you'll split your current into 2 parts, but then when you come back on the left side, the 2 currents will reunite again. So here you're going to have your, this will be your I2 coming up again, and here you're going to have your I1 coming up this way, and then once they join again at this node, they come out as your I again, as your total I. We're going to look at more how we can analyze circuits in the next couple of sections. So again, this is a case where we have 2 elements in parallel. So they're not connected one after another, they're connected at the same point to the battery. So both of them are connected at the end of their leads. Now that we know how we can connect elements in a circuit, how can we use our devices, our voltmeter and ammeter, to measure the voltage and the current in a circuit? And we need to know that we have to connect them in different ways. So for example, for the voltmeter, the voltmeter must be connected in parallel. So just like the last example with the two resistors, if you want to measure the voltage, you had to put it across a device or across the battery positive and negative side, or perhaps on each side of the your load or your resistor. So let's make a little diagram here. Let's draw the battery here on the, let's draw it here. So let's say this is our battery, right? And we, in this case, let's say we have a couple of light bulbs connected to this circuit. So we have one light bulb here, and then maybe we have another light bulb here. So if you want to measure the voltage of this, you will have to connect your voltmeter on one side of the battery and then on the other side of the battery. So this is going to be a voltmeter. You're going to stick your leads from the voltmeter on the plus side and on the negative side. Okay, so this will show you the voltage. You can also stick the voltmeter, for example, across one of the elements in your circuit. You can, for example, measure the voltage drop across this first light bulb. So you can stick the voltmeter here, and we'll show you the voltage drop along the first light bulb. You can do the same thing on the second light bulb, or again, if you put it here and here, you're gonna get the same reading as on the one on the left. So again, for the voltmeter, you just connect it. You'd have to break the circuit. You just connect it in parallel to whatever part of the circuit you want to measure the voltage. Now for the ammeter, which measures the current, which again is the amount of electrons that flow through the conductor, we had to break the circuit apart and connect it in series. So because this is because the ammeter measures the current through the circuit, so we had to break the circuit apart and actually insert the tool, the measuring device, so it lets the current flow through the device and tell us what the actual current is. So in this case, if you have to measure the current of something, let's say we have our battery here, and let's say in this case we just have we broke the circuit there. Let's just say we have a simpler circuit. This time we just have one light bulb. We're not going to bother with two. Okay, so we broke the circuit right here. In order to measure the current, so remember this is the current is going to go this way from positive to negative. We need to break the circuit, insert the ammeter tool. This will allow the current to go through the device, exit on the other side, and then it will register the actual current. So at home, maybe your dad has a multi-tool, like a multimeter, which will probably able to measure the current, so amps, and the voltages, so volts. And it probably can do both AC and DC currents. But again, in this case, we're talking about dedicated devices to just measure one thing, just to measure the current and just to measure the voltages. And again, as I already mentioned, there are two types of currents. There's DC current, which stands for direct current, or also known as continuous current. Which means that, again, the current flows continuously in one direction. And AC stands for alternating current, which means that it alternates the direction of flow. And in the case of home electric circuits, they alternate 60 hertz, which means 60 hertz means 60 cycles or times per second. So that's how many times it will switch directions. For example, here's your basic DC circuit. You have your plus and you have your light bulb here. So the current goes in one direction only. Goes in this case, it would go, if this side is plus, it will go clockwise, right? If you have AC circuit, to represent a current or a voltage source in AC, we use a little circle. This looks like a lemon circle with a little squiggly line. So this represents AC power source. So this is AC power source. And let's say we do the same thing. We stick a light bulb in here. And this would be the type of light bulb you see in your household. So Light bulb doesn't really care which way the current flows, whether it goes from one direction or the other. So for it doesn't matter whether you go in clockwise or counterclockwise direction. So the reason we use AC currents is because it reduces the voltage losses in the power lines. So that's why we use AC. Although there's high voltage power lines out there in the world that if you had the voltage high enough, you actually lose less energy. But I guess a lot of the infrastructure is already built based on the AC current. So there was a big discussion which one was better at first between Nikola Tesla and Edison. Eventually, AC was the one that people started using more, and DC stopped being used, but at least in household items. We still use DC all over the places. Like, for example, our cars have batteries, so that's DC, and your phones use batteries, so that's also DC. So we're actually able to convert from AC and DC. We do this all the time with power supplies, right? And again, as far as it sounds, AC is a little too advanced for us, so we're not going to be looking at AC circuits in Physics 11. You will look at some AC circuits in Physics 12 if you take Physics 12, but for now we're just going to be focusing on DC circuits. Now for homework, there's no questions for you to work on, but there's a little activity in your notes, which is on the second page, which asks you to basically build these circuits that we just talked about in a simulator. So there's a link that's provided already, and I will post a link on Teams, so you can also click on that. But this is where you're going to go. This is I think it's Colorado University. It's a simulator where you have all these elements on the left side. You have wire, battery, light bulb. So let's say you take a battery out and you take a wire, right? And let's say you take a light bulb and you connect it to that, and then you can take another piece of wire and build the whole circuit out. So let's say if you do a good job, basically circuits, whenever you look at schematics for circuits, they're all at 90 degrees to each other for the most part. So if you want to do a nice circuit diagram, you want to keep all the lines parallel and so on. And you can move this around. For example, you can click on it and then break it, the part you just added. Let's say you want to put a switch into this, and let's say I want another piece of wire here and connect like this. So now I have to just click on this, it will connect it, disconnect it. Now on the right here you have a panel that shows show current, and right now it's set to electrons. So you can switch it to conventional, which will go from positive to negative. So as you can see here, this is your positive side of the battery, and in this case you can also show values. Let's say right now it's set to 9 volts, but if you click on this and you play around with the slider here to increase the voltage, you see what happens to the light bulb. You increase the speed of the, in this case, positive charges flowing through the circuit, and as well as the light bulb gets brighter, right? So you can also reverse the polarity of this. Now it's flowing the other way. So your goal is to play around with the simulator, do the circuits that we just talked about, and if you have any questions, make sure you post them as comments on Teams. And again, you can also switch to the schematic. So right now this is set to schematic. You can not show any of the flow if you just want to look at the schematics. And there's a couple of tools here, a voltmeter and an ammeter. Now I do have to say that the ammeter here doesn't show what it is in real life. In real life it would be more like the voltmeter with 2 leads coming out, and you had to break the circuit apart and stick the ammeter into it. But in this case, because this is simulation, all you have to do here is just kind of hover over the wire and it will show you what the current is. Again, in real life, you have to break the circuit apart and put the ammeter in series with the circuit. Now, for the voltmeter, all you have to do is just move the leads closer to there and see what the voltage is across the battery. So right now it's set to 48 volts. If I, again, go back to and set it to like 6 volts, it will show 6 volts. Now, if I want to see the voltage drop across the light bulb, all I have to do is move my leads. In this case, I switch them around so it shows negative. So positive to positive, and I put the negative there. Shows the voltage drop to 6 volts. So we're going to talk about EMF and how it has internal resistance. So right now, because the resistance is very low, it's only 10 ohms. So we'll talk more about this again in the next section. But again, the goal here is just to play around, get to know the simulator. There's another activity after the next video. So then you'll have an idea what to do later. So for now, the goal is just to familiarize yourself with this and get to know some of the basics. And you can play around and plug in different things here. Instead of a light bulb, you can stick a fuse, you can still a dollar bill, paper clip, a coin, and so on. I think there's wire, eraser, pencil, and you can stick a dog in there. See what happens if you play around with the voltage. So this is the introduction, which is basic stuff, and then for the lab, basically, it gives you some of the components that I think are in the next activity. All right, so that's all for now. Again, if you have any questions, make sure you post them in the comments.